Hello, today we're doing lesson 6-1, solving systems of equations by graphing. This is going to be on page 313 in your book. Remember, you should be writing in your notebook all notes. I'm going to be starting notebook checks after winter break for grades, so make sure you're getting used to writing notes in your notebook now. So some of this information you're going to want to write down in your notebook. You don't need to copy it all word for word, but there's some information in here that is important, some important vocabulary. So a set of two or more equations with the same variables is called a system of equations. Right now we're just going to focus on systems of two equations. An ordered pair that is a solution to both equations is considered a solution of the system. So a system of linear equations can have one solution, it can have an infinite number of solutions, or it can have no solution at all. So here we're going to look at consistence. A system of equations is consistent if it has at least one ordered pair that satisfies both equations. If a consistent system of equations has exactly one solution, we're going to call it independent. It only intersects at one point. If a consistent system of equations has an infinite number of solutions, it is dependent. The graphs are the same line. This means there's an unlimited number of solutions that satisfy both equations. The other thing we could have is if it is inconsistent, that means there is no ordered pair that satisfies both equations. So these lines never cross because they are parallel. We're going to move to example 1, where we're going to start with classifying some systems. So we're going to use the graph to determine the number of solutions that a system has, and then state whether the system is consistent or inconsistent, and if it is independent or dependent. So here they've graphed two lines for us. We notice that right here, our lines have intersected. They have intersected in at least one place, so we are going to say that it is consistent. And it is going to be, because it is at exactly one place, we're going to call it independent. So go back to that vocabulary and look at it if you're unsure. But this one, it crosses at least one place, so it's consistent, but it only crosses at exactly one place, so it's independent. Part B. Here we see two lines that never touch. These lines are parallel, and there's no solution to the system, and therefore we are going to call this inconsistent. We don't have to have an independent or dependent because they don't cross at all. So this one is inconsistent. We're going to move on to the check, where you're going to pause the video and figure out how we would classify these two problems. So for the first one, I see parallel lines that are not crossing at all. So we would classify this one as inconsistent. Here I have two lines that cross at exactly one point. So I would say it is consistent because they cross. Consistent. And it is independent because they cross at exactly one point. Moving on to example number 2. Before that, we have another section where we need to learn. So we can solve a system of equations by graphing each equation on the same coordinate plane. Every point that lies on the line of one equation represents the solution of that equation. So all of this is a solution to this equation. Every point that Similarly, every point on the second equation represents solutions to this equation. Therefore, this one spot right here, this -1, 3, is the only solution that works for both equations. So we can write a system by setting each expression equal to y. We can graph the system, and then we can find where they intersect. So here we go on to example 2. They've set both equations to y for us already, so we don't have to do that work. So starting with equation number 1. My y-intercept is 14, so I'm going to come put a point on 14. My slope is -2, so that means I'm going to go down 2 to the right 1. Notice that we're counting by 2's here, so down 2 to the right 1 puts me at half. I'm going to keep doing that so that I can easily draw my line. You know I'm not very good at drawing straight lines. So here we go. I'm going to draw my line. This is for the first equation. I'm going to label this equation A and label this equation A so I know which one is which. Next up I have equation B. I have a y-intercept of 1, so my y-intercept is right here. My slope is 3 over 5, so I'm going to go up 3 to the right 5. So 1, 2, 3, 1, 2, 3, 4, 5. What do you know? 1, 2, 3, 1, 2, 3, 4, 5. I can now very easily graph my line. These are lines, remembering that they keep going. This is my line number B, and I can see right here, this point right here. I need to figure out what that point is, so I've got 2, 4, 5, comma, I went up 2, 4. So 5, 4 is where the two lines intersect. If I substitute 5 for x and 4 for y into these equations, both are true, which means that this 5, 4 is the solution to this system. You're going to now try a check on your own. Notice that they did not make it easy on you this time. You must get y by itself first, set them both up into slope-intercept form in order to graph. So go ahead and pause the video now and work out this check and come back and check your answers. So I'm going to do A and B again. So A, I have 3x plus 5y equals 10. I'm going to subtract 3x from both sides because now I'm trying to get y by itself. Now I have to divide by 5. I have y equals -3 over 5x plus 2. So here's my equation A. I'm going to go ahead and graph that. My y-intercept is 2. So here's my y-intercept. I'm going to go down 3 to the right 5. So 1, 2, 3. 1, 2, 3, 4, 5. I'm going to do it again just to make it easy on myself. 1, 2, 3. 1, 2, 3, 4, 5. I'm going to go ahead and draw my line. And I'm going to label my line A. Now I'm going to come back and I'm going to do B. I have x minus 5y equals -10. I'm going to first subtract x from both sides. So I have -5y equals -x minus 10. I'm going to divide by -5 on both sides so that I can get y by itself. So negative makes this positive, but I've got an invisible 1 here, so this is going to leave me 1 over 5x. And then I have -10 divided by -5, which is going to give me +2. So my y-intercept is +2. So I'm going to go here. Oh, looky there. I'm going to go up 1 to the right 5. So up 1 to the right 1, 2, 3, 4, 5. Up 1 to the right 1, 2, 3, 4, 5. Here I can draw my second line. This is B. And I can see that my lines are intersecting right there on my y-intercept. This, I don't have to move anywhere, so my x value is 0. My y value, however, is 2. So the solution to the system is 0, 2. Moving on to example 3. We're going to graph the system and determine the number of solutions that it has. If it has one solution, determine its coordinates. So we're going to have to do the same thing that we just did in the check. We have to make them both equal to y. So here I have my A and my B. So for A, I have negative 3x plus 2y equals 12. So I'm going to add 3x to both sides because I'm trying to get y by itself. So now I have 2y equals 3x plus 12. I need to get y by itself, so I'm going to divide by 2. Y equals 3 over 2x. 12 divided by 2 is 6. So let's go ahead and graph that. I've got a y-intercept of 6. And then I'm going to go up 3 to the right 2. Still counting by 2, so 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. I'm going to draw that line. This is line A. And I'm going to do line B. I have 6x minus 4y equals 8. I need to get y by itself, so I'm going to go minus 6x minus 6x. Negative 4y equals negative 6x plus 8. I'm going to need to divide by this negative 4 to get y by itself. Divide by negative 4. So my negative is going to make this positive. I have 6 over 4, which I'm going to end up simplifying later. And then 8 divided by negative 4 is going to be negative 2. So I talked about simplifying this. Both of these can be divided by a number. Both 6 and 4 can both be divided by 2. So I'm going to divide both of these by 2. 6 divided by 2 is 3 over 4 divided by 2 is 2. So now I'm just going to rewrite everything else. And this is going to be my equation for line B. So I'm going to start at a y-intercept of negative 2, which is going to be right here, because remember we're counting by 2's. And I'm going to go up 3 to the right 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Then I can't do that anymore. So I'm going to go ahead and draw my line. So I know two things here. I see that on my graph they never cross. I can see that they have the same slope. So therefore these lines are parallel. And because they intercept, this has no solution. They never intercept, so there is no solution to this problem. And then that is the end of this video.